System administrators form the backbone of modern organizations' IT infrastructure. They maintain, secure, and optimize critical systems that businesses depend on daily. In 2024, over 420,000 professionals work as system administrators across the United States. What is a system administrator? Understanding the core role and responsibilities. Day-to-day duties. The typical workday of a sysadmin. Key skills and tools. Technical and soft skills required for success. Career outlook and trends. Future of the profession and growth opportunities. 1960s to 1970s. Mainframe era with centralized computing. 1980s to 1990s. Rise of personal computers and client-server models. 2000s to 2010s. Internet expansion and virtualization. 2020s. Cloud computing and containerization. Definition. An IT professional responsible for managing, maintaining, and securing an organization's computer systems and networks. Core function. Ensures all IT infrastructure operates efficiently, securely, and reliably to support business operations. Position. Works within IT departments across industries, from small businesses to large enterprises. Setup and configuration. System administrators handle the initial deployment of hardware and software systems, ensuring optimal configuration for organizational needs. Security and maintenance. Protecting sensitive information through regular system updates, security patches, and implementing robust protection measures is a critical responsibility. Troubleshooting. When technical issues arise, system administrators diagnose and resolve problems quickly to minimize downtime and maintain business operations. System administrators perform these crucial tasks to ensure an organization's IT infrastructure runs efficiently and securely at all times. Physical server deployment. Racking, stacking, and configuring hardware in data centers. Virtual server management. Creating and managing VMs using VMware, Hyper-V, or KVM. OS installation. Deploying Windows Server, Linux distributions, or Mac OS. Patch management. Applying security updates and system patches. Network design. Planning optimal network architecture. Hardware configuration. Setting up switches, routers, and access points. Security implementation. Configuring firewalls and VPNs. Monitoring. Tracking performance and resolving issues. Account creation. Setting up new users in Active Directory or LDAP. Assigning appropriate access rights based on job roles. Policy implementation. Configuring group policies to enforce security standards. Implementing password requirements and login restrictions. Authentication management. Setting up single sign-on, SSO, systems. Configuring multi-factor authentication for enhanced security. Threat protection. Antivirus deployment and malware prevention through regular security updates to keep systems safe from external threats. Access control. Password policy enforcement and application of the least privilege principle, combined with regular access reviews to maintain system integrity. Compliance. Security auditing procedures and comprehensive log management to meet GDPR, HIPAA requirements and other regulatory standards. Backup strategy implementation. Setting up automated backup schedules. Version management. Maintaining multiple recovery points. Restoration processes. Recovering data when needed. Testing and validation. Ensuring backups actually work. Software assessment. Identifying required applications and compatibility. Package preparation. Creating standardized installation packages. Remote deployment. Using SCCM, JAMF, or GPO for distribution. Configuration management. Maintaining consistent settings across systems. System administrators use specialized tools to track system health, monitor performance metrics, and identify potential issues before they impact users. Incident response. Receiving and prioritizing support tickets from users. Diagnosis. Identifying root causes through systematic investigation. Resolution. Implementing fixes and validating solutions. Documentation. Recording issues and resolutions for future reference. Workstation management. Deploying and supporting desktops and laptops. Server infrastructure. Maintaining physical and virtual servers. Peripheral devices. Managing printers, scanners, and other equipment. Lifecycle management. Planning upgrades and replacements. AWS management. Administering EC2 instances, S3 storage, and IAM permissions. Azure resources. Deploying and managing Azure virtual machines and services. GCP administration. Configuring Google Cloud resources and networking. Language. Use cases. Environment. PowerShell. User management, Windows automation. Windows. Bash. System tasks, file operations. Linux, Unix. Python. Complex automation, API integration. Cross-platform. Ansible. Configuration management, deployment. Cross-platform. System documentation. Network diagrams. Server configurations. Recovery procedures. Security protocols. Change management. Change requests. Implementation plans. Rollback procedures. Approval workflows. Reporting. System performance. Incident statistics. Capacity planning. Security compliance. Network engineers. Collaborating on infrastructure design and troubleshooting connectivity issues. Database administrators. Coordinating server resources and optimizing database performance. Security specialists. Implementing security controls and responding to incidents. Developers. Supporting application deployment and runtime environments. Security policies. Creating and enforcing security guidelines to protect organizational data and systems. Regulatory compliance. Ensuring adherence to laws and standards like GDPR, HIPAA, and PCI DSS. Audit preparation. Documenting processes and gathering evidence for compliance audits. Risk assessment. Identifying vulnerabilities and implementing appropriate controls. Policy documentation. Maintaining clear documentation of all IT policies and procedures. System administrators spend considerable time ensuring compliance with both internal policies and external regulations like GDPR, HIPAA, and PCI DSS. Uptime goal. Target availability for critical systems. RTO. Recovery time objective for key services. RPO. Recovery point objective for data loss limit. Redundancy. Duplicate systems for critical infrastructure. Operating systems. Proficiency in Windows and Linux environments is fundamental for effective system administration. Networking. Understanding network fundamentals ensures systems remain connected and communicate properly. Virtualization. Managing virtual environments efficiently optimizes hardware resources and deployment. Security. Implementing robust security principles protects systems from unauthorized access and threats. Automation. Scripting and automation skills help streamline repetitive tasks and improve efficiency. Soft skills. Critical thinking, clear communication, time management, problem solving, and stress management are essential for success. Monitoring tools. Nagios, Zabbix, SolarWinds, Prometheus, Grafana. Automation. Ansible, Puppet, Chef, Terraform, PowerShell. Support systems. ServiceNow, Jira Service Desk, Zendesk. Security tools. Nessus, Wireshark, OpenVAS, Splunk. Resource constraints. Limited time and budget. Security threats. Ransomware, phishing, zero-day exploits. System reliability. Maintaining uptime and performance. Technology evolution. Keeping pace with rapid changes. Cloud native. Shift to containerized applications and serverless architecture. Infrastructure as code. Managing infrastructure through code and version control. AI operations. AI-assisted monitoring and automated remediation. Zero trust. Advanced security models beyond perimeter defense. The modern IT landscape shows clear distinctions in how traditional system administrators and DevOps engineers approach key responsibilities. Coding. Traditional sysadmins typically have basic scripting abilities, while DevOps engineers possess extensive programming skills and incorporate code-based solutions throughout their workflow. Infrastructure. Traditional sysadmins excel in physical infrastructure management, whereas DevOps engineers focus on infrastructure as code and cloud resources. Automation. Traditional sysadmins implement moderate automation, but DevOps engineers make extensive use of automation tools for continuous integration and deployment pipelines. Deployment. Traditional sysadmins typically handle manual or semi-automated deployments, while DevOps engineers implement sophisticated continuous deployment strategies. Monitoring. Both roles prioritize monitoring, with traditional sysadmins focusing on system metrics and DevOps engineers integrating application and business performance metrics. Entry level. IT support, help desk, junior admin. Mid-career. Systems administrator, IT manager, network admin. Specialized roles. Solutions architect, DevOps engineer, cloud architect. Senior leadership. CIO, CTO, IT director. CompTIA Server Plus. Foundation for hardware and software server management. Microsoft MCSA, MCSE. Windows Server and Microsoft Infrastructure Expertise. RHSA, RHCE. Linux Administration and Enterprise Implementation. AWS Certified SysOps. Cloud Operations and Management on AWS. SolarWinds attack, 2021. Major supply chain attack affecting thousands of organizations. Compromised software updates distributed malware to customers. Sysadmin response. System administrators led incident response. They identified affected systems, isolated networks, and implemented patches. Lessons learned. The incident highlighted the need for proactive security measures. Continuous monitoring and least privilege became essential strategies. Build a home lab. Create a personal test environment with old hardware or virtual machines. Continuous learning. Stay current with cloud platforms, security, and automation. Community involvement. Participate in forums like Reddit, Spiceworks, and Stack Exchange. Certification path. Start with CompTIA A+ and Network Plus, then specialize. Critical role. System administrators ensure all technology functions properly for business success. Continuous growth. The field requires constant learning and adaptation to new technologies. Strong future. Demand remains high with evolving responsibilities in cloud and automation.